Hi, this is Harivarshan. This is my analysis of algorithm programming project, weighted interval scheduling. The weighted interval scheduling that involves scheduling a set of intervals with weighted such that the total weight of a selected non-overlapping intervals is maximized. In this problem, we are given a set of n intervals, each with start time, end time, and weight. The goal is to select the subset of intervals and that do not overlap have the maximum total weight. This problems arise in many real-world applications, such as scheduling of a job in many manufacturing process. Here we have used three approach: brute force approach, and recursive memorization, and dynamic programming with binary search. Here the brute force approach. The brute force approach is to solve weighted interval scheduling, involves generating all possible subset of intervals, then checking the maximum weight of non-overlapping intervals of each set of these subsets. This can be done recursively by considering two cases, either the current interval is included or not included in that subset. For each interval, we check if it is overlap the previous intervals. If it is does not, we include the subset recursively consider the remaining intervals. If it does, we skip and consider the remaining intervals. The time complexity of this approach is O2 power n. And this is the recursive memorization. In this, we are given a set of intervals with the weights. The objective is to find the maximum weighted of the non-overlapping intervals. This problem can be solved using different algorithms such as um, dynamic programming. In this, it calculates the calculate the maximum sum of their overlapping ending with the interval y as the maximum of weighted sum of intervals plus maximum weighted sum of a non-overlapping interval ending with the interval j with maximized sum of intervals ending with interval I minus 1. This is the dynamic programming using binary search. In this approach, it- the dynamic programming approach with binary search sorts the input intervals based on their end types and maintains two lists, DP and prev end. It uses a binary search to find the latest non-overlapping intervals to permanent interval and update the DP list accordingly. The previous list is used to keep track of the end, the time of that non-overlapping interval. The algorithm returns the last element of this TP list as the maximum weighted sum of a non-overlapping intervals. I have run this all the algorithms in Colab. This is the brute force. Here I have run this code for the different sizes. These are the sizes mentioned here. I have run this code for 5 times to calculate that average of empirical running time. And same like this, I have run this algorithm for recursive memorization. And here are the sizes of this. Here in this, I have used the different sizes for each algorithms. And this is the dynamic programming with binary algorithm. Here, these are the sizes which I have used. Even this program I have run for 5 times. And here the Excel where I got that where I have calculated that predicted RT and that empirical RT. Here the graph for that brute force, and same like this I have done for that all three algorithms. And this is a comparison of all three algorithms empirical RT. This is the graph. That's